Good morning, my dear students. Today we will talk about motion. What's meant by motion? Motion means change in object position. When the object changes its position, it means that it did a motion. Motion is the change in object position over time, because if like this duster, when it moves from this position to this position, I will say it did a motion, and of course it will take a time to change its position. So motion is a change of object position over time relative to a reference point. In this lesson we will study motion, relative motion, and types of motion. Motion happens all around us. Every day we see objects such as cars, motorbike, move in different directions. And we said motion happens when the object changes its position as time passes according to position of another object. What's meant by speed? Speed, it is the distance covered by the object in a unit time. So speed means change in the distance in a unit time. It is the distance covered by the object in a unit time. The measuring unit of speed, meter per second, and the distance, meter, time, seconds. So speed, it is the distance covered by the object in a unit time, or 1 second. Now we will talk about types of motion or relative motion. At the first we will talk about relative motion. Relative motion, we'll do this activity at the first. If you are in a moving car, and you are looking at the other car which is beside you, and both of you are moving with the same speed at the same direction. Both of you are moving with the same speed at the same direction. هما الاتنين ماشيين مع بعض with the same speed, with the same direction. When you look at the other car, you will imagine that the two cars stop moving and no motion will be observed. You will not observe any motion. You will imagine that this car it's not moving. In the other case, if your car beside a stopping car, this is your car and this is the car that you are looking at. When this car it's not moving or moving with very slow speed, a speed which is slower than yours, you will imagine that this car it's moving backward. This car it's moving backward. So you will imagine that the other car goes backward or move in the opposite direction. So this is your car, and the other car that you are looking at is stopping. It's not moving or moving but slowly, with a speed slower than your speed. So when you look at it, you will imagine that it's moving backward, moving in the opposite direction. Here in this case, this is your car and this is the other car. When your car is stopping, it's not moving, and the other car move forward beside you. So your car you are not moving. In this case, you are not moving. The car you are in is stopping, and the other car is moving forward. What you will imagine? You will imagine that you are moving backward. You will imagine that you are moving backward. In this case, your car and the other car are moving in the opposite direction. If your car moves in opposite direction of another car that moves with low speed, it's moving with low speed, not high speed, but because they are moving in the opposite direction, you will imagine that the other car is moving with very high speed. You will imagine that the other car moves with a high speed. Although it's moving with it's moving with low speed. This is the relative speed. Relative speed, you are comparing your or relative motion, you are comparing your motion with another object, like the car, the other car, you are looking at the other car, or a tree or lamp post. You are comparing your motion by another fixed point, or we will call it a frame of reference. So relative motion is the change in object position or direction as time passes relative to object or fixed point, the other object or the other car that I'm looking at. We will call it frame of reference. Frame of reference. The reference point is the fixed point used to determine the object position or describe its movement. It is the fixed point that you determine, used to determine object position or describe its movement. Now we will talk about types of motion. There are two types of motion: transitional motion or periodic motion. Transitional motion or periodic motion. What is the difference between them? Transitional motion, it has starting point, or we will call it initial point and final point. Initial position and the final position. Like when you go to the school, you have a starting position, which is your home, and the final position, which is the school. Periodic motion, it's motion which is regularly repeated in equal periods of time. Again, transitional motion, it is the motion by which object position change relative to a fixed point or a frame of reference from time to time between initial and final position. Between initial position and the final position, it has a starting point and the ending point. But periodic motion, it is the motion which is regularly repeated in equal periods of time, and also it takes equal periods of time. Examples of transitional motion: the motion of a person's motion, because he has a starting point, initial position, and the final position. Bicycle motion, a train or car motion. All of them, they have starting position and final position, initial position and the final position. But periodic motion, as we said, it is the motion which is regularly repeated in equal periods of time. It repeats its motion. And it has three types, which are a vibrating motion, circular motion, and wave motion. Vibrating motion, circular motion, and wave motion. Vibrating motion, it is like the motion of the simple pendulum, because it vibrates on right and left sides of the rest position. We will call it vibrating motion. Circular motion, like the motion or rotation of the moon around the earth, and also the earth around the sun. It's an example of a circular motion. Wave motion, a motion of the water waves, like water waves produced when we throw a piece of stone or a cork in the water. It will make water waves, or we will call this motion wave motion, like water waves. Another example of circular motion, like the motion of the fan. Motion of the fan also is considered a circular motion because it's regularly repeated in equal periods of time. Now we will talk about wave motion. So we said that the motion is two types: transitional motion and the periodic motion. And we said periodic motion is vibrating, circular, and wave motion. We'll talk about wave motion. We can classify wave motion into two types: mechanical waves and electromagnetic waves. So we are classifying wave motion, which is a type of periodic motion, into two types: mechanical motion and electromagnetic motion. electromagnetic waves, mechanical waves and electromagnetic waves. What is the difference between mechanical and electromagnetic? Let's see. We are classifying wave, motion, types of waves into two types, mechanical waves and electromagnetic waves. Mechanical waves, they need medium to transfer or to propagate through. They need medium. What is the meaning of medium? Medium means solid, liquid, or gas. But electromagnetic waves, they don't need medium. Don't need medium. So they can travel or they can propagate through vacuum. Vacuum means space. But mechanical waves, they need medium, as I said, solid, liquid, or gas, so they can't travel through vacuum. Can't travel in vacuum. So again, what is the difference between mechanical and electromagnetic waves? Mechanical waves need medium, but electromagnetic waves, they don't need medium. Mechanical waves, because they need medium, they can't travel through vacuum. But electromagnetic waves, they don't need medium. If there is medium, it's okay, they can travel. But if there is no medium, of course, also they can travel. They can travel in vacuum or space, in medium and non-medium, both of them. Electromagnetic waves, they have very high speed, or very high velocity. Its speed reach 300 million meter per second. Their speed reach 300 million meter per second, but or 3 times 10 power 8 meter per second. But mechanical waves, they have relatively slow speed. It's slower than the electromagnetic waves. Like the sound waves, its speed reach 340 meter per second only. So electromagnetic waves, their speed is very high. It reaches 300 million meter per second. But mechanical waves, their speed is relatively slow. Like the sound waves, they reach 340 meter per second in the air. Mechanical waves and electromagnetic waves. Mechanical waves, they are waves which need medium to transfer through. But electromagnetic waves, they are waves which are accompanied by electromagnetic force. Of course, their name is electromagnetic waves, so they need electromagnetic force or accompanied by electromagnetic force. And they don't need medium to travel through. Their characteristics, mechanical waves, they are produced due to vibration of the medium. Of course, they need medium, so the medium particles will vibrate like the water waves. The water particles will vibrate. Also, mechanical waves, they don't travel through free space, or they can't travel through vacuum because they need medium. Their speed is relatively low. Or they are slower than electromagnetic waves. Electromagnetic waves, they are accompanied by electromagnetic force. Their name is electromagnetic waves. So they are accompanied by electromagnetic force. They can spread in all media and also free space. They don't have any problem. They can transfer in all media, solid, liquid, and gas, and also they can travel through vacuum or free space. Their speed is extremely high speed, which is equal to 100 million meters per second. Examples of mechanical waves, we have only two examples, which are sound waves and water waves. Sound waves and water waves, they are mechanical, which means that sound to travel, it needs medium. If we go to the space, we can't hear our sound, or the sound of astronauts can't be heard if it is in a mechanical waves, because sound is a mechanical waves, and also water waves. Examples of electromagnetic waves like light waves, microwaves, radio waves, X-ray, gamma ray, ultraviolet, and infrared, which emitted from the sun. Give reason, we can receive the sunlight, but we don't hear the sound of solar explosion. Why? This is the sun. And this is the earth. Sun will send its sunlight into the earth. This sunlight will reach to the earth. But the sound of solar explosions, we can't hear the sound of solar explosion. Why? Because sunlight is electromagnetic waves. It's electromagnetic. But sound of solar explosion is mechanical. Electromagnetic waves, they can travel through vacuum. The sunlight is electromagnetic wave, which can travel through vacuum. But sound of solar explosion is a mechanical waves, and it can't travel through vacuum. It can't travel through vacuum, so it can't move in the space and to reach the earth. So we can receive sunlight, but we don't hear the sound of solar explosions, because sunlight is electromagnetic waves, which can travel through the space, while the sound of solar explosions is mechanical waves, which can't travel through space or vacuum. Also, we can see lightning before hearing the thunder, although they occur at the same time. Because lightning is electromagnetic waves, but thunder, it's a sound, it's a mechanical wave. And the electromagnetic waves is faster, it has very high speed than the mechanical waves. We have technological applications on waves. At the first, we will talk about mechanical waves. Mechanical waves, we can use it in examining and curing equipment by using sound waves or ultrasonic or sonar devices like ultrasonic waves. Now we are talking again about mechanical waves, like as we said mechanical, two examples, sound and water. So most of these applications is about sound. Examining and curing sets or equipments for human body by sound waves or ultrasonic waves. Musical instrument like stringed musical instrument contain strings like violin, lute and guitar, and also pneumatic musical instruments like flute and reed pipe. Both of them, they produce, any musical instrument produce sound, so it's mechanical waves. Also amplifiers and devices of distributing and controlling sound using in broadcasting studio. So in the broadcasting studio they use sound waves or depend on sound waves, which is a type of mechanical waves. Now we'll talk about applications of electromagnetic waves. Electromagnetic waves like ultraviolet waves. Ultraviolet rays, they are used in sterilizing of surgical and operation rooms. Ultraviolet has the ability to sterilize the sets of surgical rooms. Also another example of electromagnetic waves, X-ray. X-ray, it's used in photographing bones. Of course, all of us, we know the X-ray, we can use it in photographing bones to detect the site of fractures. And also examining metals in industry, we can use it in examining metals or mineral raw in industry and showing errors and pores, cracks in these minerals. We use it in industry in examining of minerals or metals, and also studying inner structure of mineral crystals. This is X-ray. Also we have gamma ray. Gamma ray, it's used in medical purpose as treatment of and the discovery of swelling or tumors. When I hear swelling or tumors, الأورام, this is a gamma ray. Visible light or seen light, it's used in photographing camera. Visible light or seen light, it's used in photographing camera, television camera, and also light show or data show. This is visible light or seen light, the light that we can see it. We have another example, which is infrared. They are used in night vision sets used in modern military forces. Night vision, رؤية الليلية, we use infrared in night vision system. And also we use it in remote sensing instrument to photograph the Earth's surface by using satellites. So we use it to make remote sensing instrument to photographing Earth's surface using satellites. And also we use infrared in cooking food. Why? Because infrared has a thermal effect, has a heat effect property. Also we use infrared in making remote sets to control and operate electric sets like television, DVD and air conditioner. So we use it to make a remote. Remote for what? For television, DVD and air conditioner. Ultraviolet we use it in medical purpose because it's used to sterilize sets in operation rooms. Also X-ray, we can use it in medical purpose because we use it to photographing bone. Gamma ray, also it's used in medical purpose because it's used in treatment and the discovery of swelling and tumor. Infrared and the visible light are used in photographing. Infrared used in photographing because it's used in photographing Earth by satellite. And the visible light also, it's used in photographing because it's used in photographing camera. Thank you, Prep1.